Good morning, everyone, and thank you very much for joining us for today's webinar, Lifting Barriers, Vertical Transportation, and Inclusive Access. My name is Shalika Sivathasan, and I am the Administrative Assistant in the Continuing Education Department at the OAA. We will begin today's webinar by acknowledging the land on which we are meeting and calling in from. For millennia, the place we call Ontario has been inhabited by Indigenous peoples and nations who have been stewards of the land and who are deeply connected to its rich cultural and natural landscape. We would like to invite you in a moment of reflection to acknowledge our shared responsibility to address past and present injustices and provide space for Indigenous knowledge and worldviews to shape the architectural landscape of Turtle Island. Before we begin, I would like to share some important information to ensure an effective and professional webinar experience. Please be informed that this session is being recorded for quality and educational purposes. For accessibility, we provide automated closed captioning service available in multiple languages to accommodate the needs of our diverse audience. In order to maintain a stable internet connection, we have muted all participant microphones and disabled video feeds. Kindly note the chat function has also been deactivated. However, we do highly encourage engagement through our Q&A window, which you will find at the bottom of your screen. Feel free to submit any questions you have for our speakers there. Questions will be addressed during the designated question and answer period at the end of the presentation. For those seeking continuing education learning hours, please note that attendance is crucial. A minimum of 80% attendance is required for these hours to be accredited to your OAA transcript. Please just allow a few weeks for the processing and reporting of these hours. And lastly, please note that the presenters do not provide insurance, legal, or practice advice, and the OAA does not bear responsibility for errors or omissions in discussions during the webinar. Now, I'm excited to introduce our speakers for today's session, Eric Peterson and Devin Wolsey. Eric is President and CEO of GUNN Consultants, overseeing operations across Vancouver, Calgary, and Toronto. He graduated from Lake University with a Bachelor of Engineering in 1994 and began his career in the engineering consulting industry. Eric is a registered professional engineer and qualified elevator inspector. Having been with GUNN since 1998, Eric brings a vast wealth of experience and expertise in vertical transportation, including new construction, modernization, inspection, and asset management. Based out of the Toronto office, he continues to shape the industry and drive innovation across Canada. And Devin is the branch manager in Toronto at GUNN Consultants, overseeing operations across Ontario. Devin is a registered elevating device mechanic Class T with technical standards and safety authority. With 25 years in the vertical transportation industry, he began his career as a field supervisor in new construction and modernization. His experience spans project management, inspections, business development, and technical operations. Before joining GUNN in 2025, Devin was a director at one of Ontario's largest independent elevator companies. So now, please join me in welcoming Eric and Devin.
Great. Thanks, Shalika, and welcome everybody. The topic for today, as advertised, is lifting barriers, vertical transportation, and inclusive access. So the agenda for today, a bit about who we are, standards and code, inclusive features, smart tech, user safety and comfort, the benefits of inclusive access, and future trends that we're seeing in the industry pertaining to inclusive access. So a quick slide about who we are as a company. GUNN Consultants, we're a vertical transportation firm. That's what we specialize in. We're independent. We're not tied to any supplier. We're an engineering company, much like a mechanical engineering or electrical engineering company. We've been around for 40 plus years. We were incorporated in 1983. We have offices in Toronto, Calgary, and Vancouver. And yeah, many projects on our resume, and we do work in new construction, modernization, and maintenance and asset management. So basically anything vertical transportation, anything escalator, elevator, moving walks, we're involved in it. So standards and codes, and at this point, I'm going to turn it over to Devin. I'm just going to talk a bit about what codes pertain to inclusive access.
Hello, everyone. My name is Devin, as Eric mentioned, and standards and codes. So we have the building code, which is that incorporates as a National Building Code of Canada, as well as in Ontario. We always have the Ontario Building Code, and then across Canada, the Alberta Building Code, BC Building Code, etc.
I think the building code in Canada, there are a number of elevator requirements, of course, and talk about accessibility in buildings, but there are probably four key ones that I wanted to highlight. First is, this is all references from the National Building Code, but as Devin said, these are basically the same, it's almost identical code requirements as you will see in the Ontario Building Code. There are minor amendments, but not really as it pertains to these requirements. So the first is that you need a barrier-free path between the entrance story and other normally occupied floor areas. So it must include an elevator or other elevating device, not specifically an elevator, things like, according to the building code at least, a disabled person's lift, a Lula lift people have probably heard of, or a ramp, quite frankly. These are all acceptable means of providing vertical transportation access between levels in a building. If it's a high building, you do need one firefighter's elevator. That is something to be aware of. All elevators must be stretcher accessible. Actually, all elevators is not technically correct. I should say all buildings must have one elevator accessing all floors that shall be stretcher accessible. So if you have a pair of two elevators, only one of them has to be stretcher accessible. And we're going to talk about this in more detail, but all elevators, this part is accurate. All elevators must meet Appendix E of the CSA B44. If you look in the actual, this is the elevator code, of course. If you look in that B44 code, it will say this is a non-mandatory part of the code. Where it becomes mandatory is the building code. The building code specifically says you must comply with the Appendix E requirements.
I think it's important too, because there's a lot of stuff that we're going to talk about today that the building code doesn't necessarily make mandatory, but what we just highlighted does. So we'll get into some stuff later on that isn't necessarily mandatory by building code, but maybe by municipal standards and various other requirements that we're going to discuss. So this one here is stretcher accessibility. What we try to do here is just look at an elevator in Ontario. Right now we have a stretcher that is designed in the building code states the stretcher size, which fits into those types of elevators, right? So we have basically our industry is considered a 2,500 pound car, the quote unquote stretcher size elevator with a side entrance. Whereas a center opening door, for instance, on a 2,500 pound car will not fit a stretcher. So you can see all those drawings there show that building code required stretcher, and none of them have a center opening door because the center opening door won't allow the stretcher to go in and turn and fit within the elevator. And then you have what's on the right-hand side. You have a much more, what we traditionally would call like a hospital-style elevator that's deeper than it is wider. Obviously, clearly fits a stretcher. It's a 5,000 pound elevator there that we show. Everything in our business too. We're going to talk a lot about. I mention capacity every once in a while, but also size. Capacity is size in our business. So there's a requirement in the code. If you have a certain amount of capacity, you have a certain amount of floor space in the elevator.
Couple maybe subtleties that have come up specifically on projects. You notice the diagram on not the far right, but in the drawing on the far right with staggered entrances. In a standard 2,500 pound elevator with side parting doors, if you have front and rear, in order to provide stretcher accessibility between one level that has front and one level that has rear, you do need to stagger the entrances. Because what you will find is if you try to move it in the front entrance and then rotate it and move it out the back entrance, if the entrances are aligned as in the middle drawing, you will find it does not fit, not with the standard at least. And I think the other thing that's not shown here is another standard, so to speak, that's considered to be stretcher accessible is a 3,500 pound cab with a center parting door, right? So if you have a center parting door, you got to go to the larger cab. I think the thing I would want to caution people on is to be pay a lot of attention to the cab sizes from the vendors, because a lot of the products that are coming out we see is particularly machinerless elevators have unique cab sizes, and they would not be exactly, it might be a 3,500 pound cab with center parting doors, but the dimensions will be slightly different than you would be used to seeing. And we found cases where they in fact don't fit a stretcher. So you cannot just assume that because it's 35 center parting, or for that matter 2,500 pound side parting, you can't assume it's going to be stretcher accessible. It does need to be checked.
I think also a note too about the stretcher size in Ontario currently, it is not the International Building Code stretcher size. That stretcher is actually larger than what the Ontario Building Code requires. So if you are designing to a different standard there that requires an International Building Code stretcher, it is actually like a 3,500 pound car that Eric had mentioned would actually fit the International Building Code stretcher inside. So especially if you're looking at like from some US based documents, especially from some of the elevator suppliers, their stretcher requirements may look a little different because they didn't take Ontario into consideration. Appendix E. So like we said, this is required by the building code. It's, you know, as Eric mentioned, it's in the elevator code. If we took just the elevator code's definition, this isn't a non-mandatory appendices, but because the building code makes it requirement, it is required in Ontario.
I think that actually makes me think of an assumption that gets made quite often that, oh, they're TSSA inspected, right? The elevators are inspected by TSSA, therefore they must be checking things that are in Appendix E. They may or may not, but it certainly is not their responsibility. That's very important to know. It's from a building code perspective, from your letters of assurance, it's whoever's signing off that needs to be certain that you're meeting these requirements. So I think that's something to be aware of. Do not assume the TSSA inspector is checking these things that Devin's highlighting.
It's a good point, because they're not there to check building code. They're to check the elevator code. They're not there to check building code. They may take it upon themselves to do so, but that's not their requirement. So cabin door size requirements. So you can see here that, you know, we've got, you know, various different size doors and stuff like that with the minimum requirements. It's really important to pay attention to some of those inside car requirements that are there as well. Then they're spelled out there, which again, you're not going to be able to find. You're not going to be able to go to an elevator supplier and find it's all about capacity in our business, and those relate to the sizes in the cars.
Those are all based on, and we'll get into it in a slide that's coming up, but they are based ultimately on having a 1,500 millimeter turning radius within the cab. So that's kind of the fundamentally what this is based on. So these are not the only dimensions that would work, but they are kind of the minimum dimensions that would work for different arrangements.
Having handrails on all non-access walls. A non-access wall for an elevator would be a non-door wall. So if you had a front-only elevator, you're going to have 3 handrails, one on the left-hand side, one on the right-hand side, and one on the back wall. You're not going to have it on the door wall. So on a front and rear elevator, you're going to have 2 sets of handrails, one on the left, one on the right, and not one on the rear. Cab illumination is minimum 100 lux. So this is important. Just there is actually some requirements that cross here, like we're going to be talking about, you know, CNIB and Rick Hansen Foundation and some of their requirements, which match some of these Appendix E requirements. One of them is going to be cab illumination, minimum to be 100 lux. Door reopening device, non-contact. So basically, like if you know any modern elevator, I'm sure you've all seen older elevators though too that have a mechanical safety edge. That would no longer meet the Appendix E. So if you're putting your hand out between the doors should reverse without contacting you. Newer code actually requires a step above this, which is a 3D door detection system, but Appendix E doesn't require it. But there is parts of the code that supersede this part that would actually require a 3D door detection system under the code that's currently enforced in Ontario, which basically we will talk about a little bit later on. Car and hall button heights, 35 to 48 inches. So this dictates both the hall buttons and the car button heights. I think this is important, especially for the hall button heights. If you're looking from, you know, the car a lot of times is, you know, you're taking from the vendor and stuff like that. But the hall buttons, you know, it's really important that the hall button heights, because those are those boxes that are put in during construction or from the design phase when you're looking at your lobby design and stuff like that, making sure that your hall button heights are at the right requirement, especially on the main floor hall station, because the main floor hall station, you're going to have additional possible boxes or indications like fire service boxes, emergency power switch gear, all that sort of stuff could be located at the main floor haul station. Making sure the requirement though for the haul button itself, the button that's going to call the elevator, is between that 35 to 48 inches. And that's for the button itself, not the box, not the plate, for the button.
I think also something to be aware of is in very high buildings, you generally will not be able to fit buttons within one panel for all the floors within 35 to 48 inches. So you generally, if it's say a 50-60 floor building, you will typically have to split the buttons between two panels. So just to be aware of that, because it's fairly restricted. They used to be able to go up to 54 inches, but that's no longer the case.
Car button designations. We were just talking about this morning, actually, before we were coming to do the presentation. This one's probably the most commonly one missed. Is floor designations are actually for below ground floors. It's not P1, not P2. It's -2, -1, 0, 1, and 2. So 0 being the main floor typically in the building. Was what Appendix E is looking for. This is kind of adopted from, like, almost quite honestly across the world, essentially. I think is where a lot of this stuff comes from. So this is what's required in Appendix E, and something we don't see all the time by any means, or not if ever, for sure, but definitely this is a requirement that's often missed, is the designations of the floors. One thing I've run into before too is making sure that your button designations match your floors in your building. I've had a number of buildings that have gone back and had to basically either rename their apartment floors, because this is not a requirement, but when the ambulance comes in, they don't want to be going to suite 200 on floor 1. They expect that suite number to match the floors in the elevator. And you'll have them call it, the fire department will call it out on you. So it's important to match your button assignments with your floor levels and your floor naming from that requirement, but making sure they make Appendix E.
I think how we're getting around this, we're doing a transit project right now, which has very specific naming conventions. So we're just doing duplicate designations. We're following this. We're following Appendix E. It'll be a 0 for the main entry level. Then it's below grade, of course. Well, not of course, but it is below grade. So it's -1, -2. And then adjacent those buttons, we're putting the auxiliary designation. The level where the trains are coming in, for example.
Yeah.
We would name it specifically, right?
Mezzanine platform, that sort of stuff.
Yeah.
One thing that can get tricky with that though is the length of and that's a requirement on some projects, to actually have the, dictated by an overall project requirement, is to have the length of that floor. Like, we've got to fit the whole platform level next to the hall button. So it's a design thing that's got to get caught during design, right? Because it can be something that's very hard to alter later on. So. Hall button clear floor space. So this is one that's often missed, especially sometimes during retrofits. I've been involved in a number of retrofit projects where, quite frankly, the hall button got put somewhere that was easy during construction, because it was, this wasn't really looked at. You're supposed to have this clear floor space. If you can imagine being, having disabled person access in front of the elevator, they want to be able to get there and have some space to navigate to the button. If you're having the button like on a column next to the elevator and it's not facing outwards, it's facing to the right, you're not going to meet this 30 by 48 requirement, right? So it's important to have this requirement. It's not necessarily right next to the elevator either, because you won't get that 30 inches, right? So this is an important one that, again, is often missed. So it's 30 inches by 48 inches clear floor in front of the button itself to provide accessible space.
And if everybody could just kind of file that away, 30 inches by 48 inches, we're going to have slightly different requirements based on which regulation you follow. And they're going to be slightly different than this. So just file that away, 30 inches by 48.
Tactile braille markings for car buttons and hall door jambs. Everyone's probably been in an elevator before. Typically next to the button, you do have a braille marking. That braille marking is going to match the designation that we talked about before, -1, -2, 0. And then, as Eric mentioned, we're going to have, like, say, platform level in a transit thing. That's not necessarily braille. I mean, it could have braille underneath it, but the actual floor label, the button itself, is going to have 0, -1, -2 next to it, or +1, 1, 2, 3, 4, all the way up. And then hall door jambs also, like, I don't know if people recognize this, but on the jambs, which is the entrance area by the door, you are required to have, again, that designation that matches the button 0, 1, 2, 3 all the way up, or -1, -2 on the way down, with that adjacent braille next to on the jamb plate in the door jamb. It's also important to note, like we were discussing before this as well, is that it's actually not required on the button in the hall. This is only in the door jamb itself. The buttons in the halls don't require a braille marking. They're there. Car position indicator. So this, again, that spells it out there. It's in the car. So not necessarily in the hall is it required, but a car position indicator is what we're talking about. So inside the elevator, it doesn't dictate in this code anyways about where it's located necessarily, but the car position indicator is in the car, sorry, showing the position of the car. Is it at what floor is it at currently, and then when you get there to the floor, what floor it is at. Audible position indication. So again, this is like we talked about here. There's going to be some different codes and requirements, not necessarily codes, but other accessibility standards that we're going to talk about in a bit. But this one is an Appendix E for cars over 200 feet per minute. So cars over 200 feet per minute, you know, if you have 6 or 7 floors and above, you're probably doing over 200 feet per minute. You are required to have voice enunciation. It has to provide the position and the floor that the elevator is at. So when the doors are opening, I'm at floor 6. And then the direction of travel typically as well. But it's very important that that's looked at. You'll see this is a lot more commonplace than it used to be. And then in some, depending on, it doesn't say in Appendix E, I don't believe, but for both French and English is a lot of times a requirement depending on the building you're working in. Emergency communications audio. So for quite some time now in the code, we've had hands-free voice communication for emergencies. So you press the phone button in the elevator, you're going to be connected to a 24/7 call center that's going to know where you are and if they can hear you clearly. That's the code requirement for it, and that's just Appendix E. We're making that requirement for audio emergency communications. Visual and audible indication of direction indication. So lanterns. So lanterns in the car. Again, which direction is the elevator going? Is it going up? Is it going down? And then also gongs as to the position of the elevator is going up and the elevator is going down. A certain audible indication of that for people that have low sight. Now on to AOTA. AOTA is kind of, I'm sure everyone here has heard of AOTA, and quite frankly, we're doing a lot of AOTA work across the province for the Infrastructure Ontario projects, where they're actually making sure they're going back to existing buildings and catching up on some of the AOTA requirements that weren't enforced at the time the building was built, but are going back and either doing some other level 1, level 2, or level 3 requirements, which we're going to get into in this section. So they've been effective as of 2005. Which is quite some time ago, as you know, and we're still playing a little bit of catch up across Ontario, quite frankly. So this is what mandates accessibility for buildings in Ontario. Again, this isn't necessarily across the Canada, and then the AOTA took into a lot of effect from various places when they created AOTA, from Rick Hansen Foundations to CNIB, taking some of those requirements, not all of them, but trying to create a standard here that was above and beyond what we had seen in the past. So elevator accessibility requirements outlined in Ontario Building Code. The OBC requires compliance with Appendix E, as we noted before. Province provide additional requirements and guidance across Ontario. So compliance is divided into 3 categories. Again, this is for AOTA. Level 1 is Ontario Building Code compliance. Level 2 is enhanced accessibility low cost. And level 3 is enhanced accessibility significant cost. So what they're looking at is trying to divide, like if you have an existing building, what should you be doing to make your building AOTA compliant? Level 2 is in addition to level 1, some optional requirements depending on their cost impact. You should go with those. Level 3 is typically for buildings like new construction. So if you're building a new building in Ontario that is a government building, you will adhere to the level 3 requirements. Also, if you want to make the claim that you're going to be an AOTA compliant building in a new building, you should be meeting the level 3 requirements. We're going to go into each of those.
I think Devin touched on it, but just, and it's up there on the screen, but just to be clear, this is the barrier-free design guidelines specifically for Ontario government facilities. So that's what this pertains to specifically. And that's where this notion of this level 1, 2, and 3 compliance comes from.
So level 1 compliance, minimum mandatory. So the first statements actually comply with level E, so Appendix E. So Appendix E we just talked about, that's the level 1 base requirement, is make sure they meet Appendix E. So they're gonna make you meet all the stuff we just talked about. Emergency communication, audible, no music. So they're just making sure, they're basically, we already had the audible requirement. They're basically stating that you shall not have music playing in the background to confuse people or to not be able to hear emergency messages, that sort of stuff. Back wall shall have a mirror. Side walls shall not be used. Well, it's important. We've all been on lots of nice elevators or even normal elevators that aren't too nice. And some of them have mirrors on all the walls. I think the idea here is it's just confusing to people, especially in a wheelchair or if you're low sight, to see all these, you know, basically a hall of mirrors, essentially, if you're in an elevator in a small space with a lot of mirrors. And having that mirror on the back wall really does help facilitate, you know, backing up of a wheelchair or mobility devices. Loose mats and flooring not permitted, especially in the winter in Ontario. You'll see buildings put mats in, even in brand new buildings. They'll put mats inside the elevator to you know basically protect the floors, get the water and the grunge out of the floor. This is actually, honestly, in my opinion, never been okay anyways, because none of those mats are actually fire rated to the elevator code. But they're basically, from this requirement from an AOTA perspective, they don't want those mats tripping anybody up, especially people that that have low mobility. Platform lifts. So this is an interesting one because the code kind of differs across Canada. Again, this is AOTA, but platform lifts permitted only if users can independently operate them. Key activation is not acceptable. Well, in Ontario, all platform lifts have keys. You cannot have a platform lift in Ontario that is not key operated. So there is a key and an authorized user in the building that's been trained on the platform lift. And this is why platform lifts, stair lifts, that sort of stuff, vertical Cs, which you can see in the picture here, have not been barrier free in Ontario for some time because of this statement that you cannot have a key acceptable device, which is those two devices in the picture, which I'm sure we've seen many of them are not permitted. So if you've got stairs at the front of your building and you've got, like Eric had mentioned at the start, if you're coming into your building and all you've got is stairs, you cannot have a platform lift and meet the level 1 compliance because it's going to be a key activated device.
Because you know what happens, right? I mean, yeah, we've been in these buildings and the lift's there, great. In theory, it operates. No one knows where the key is. So someone arrives, they don't know who to ask.
Yeah.
There's generally nobody there. So that's the problem. That's the fundamental issue. So as much as these provide some accessibility, they don't meet level 1.
Right. And then just even asking that person is creating a barrier to person, right? They're walking in the building. They just want to get in the building. They don't want to be bugging people. They don't want to be waiting for the key holder. Like Eric said, we have no idea where the key is today and now you can't get in the building, right? So it's really important. These devices in Ontario are kind of going the way of the dodo bird. LED messaging system to enable communication for persons who are deaf or hard of hearing. So this is important. Again, this is kind of part of the new 2019 code in Ontario, but this is a requirement of a level 1 compliance for AOTA. It's basically to have, and we talked about having emergency communications being audible. Now they're dealing with people that maybe possibly can't hear or deaf or hard of hearing, right? So now we have a visual messaging system in the elevator, and this is pretty much a requirement for all new elevators in Ontario. But you have basically the ability to text into the elevator, and then there's a series of buttons in the elevator, and those people in the elevator can do yes or no questions to answer those questions proposed by the emergency operator. We're going to get into a little bit more of that in a bit as well. Level 2 compliance. Call button. So I remember Eric talked about some of the stuff in here. These are the call buttons. So this is inside the elevator.
30 by 48. That's what I remember.
Yeah.
Yeah. So this is not a lot bigger, but a little bit bigger. Right?
Yeah. So it's getting a little bit bigger. And then panel centered on clear floor space. So that one's important too, is that the panel is now centered, not where it's typically kept in the elevator. So it's an important one to talk about. Mirrors should be included on the back wall. We talked about that already. One of the requirements is actually, which we're going to get into in a bit as well, is a flow through elevator cab. But basically the mirror on the back wall is a requirement to allow, again, for low mobility devices. Color contrasting. This one's one that, quite frankly, we haven't been struggling with. We have an in-house cab designer, and we did a lot of research into this contrasting minimum. I always thought contrasting would be like, we'll have yellow over here and we'll have green over here. That doesn't necessarily meet the contrasting minimum color. What we're trying to do here is basically provide definition between the floor, the wall, the hall button, or sorry, the car button inside the car. So we're trying to create very distinct different visual elements within the elevator to help people who are low of sight define where they are within the elevator itself. So color contrasting minimum 50% should be used to differentiate key elements of the elevators. It means you're going to be a little bit more restricted within your cab design, frankly. Your floors are going to be dark and your walls might be light. But it's stuff that, you know, we've done a number of projects now where we're assisting clients to pick some colors that are, you know, and then the floor and then the other sidewalls and stuff like that. This is actually very, very difficult to meet because you've got a number of different materials typically inside an elevator, from stainless to formica to a floor that might be ceramic. So it's really hard to get those 50% color differentiations between all the different walls and flooring in the elevator system. Hall lanterns. This is a good one too. So a hall lantern is not something that we typically would see in the past on every floor. Typically, sometimes it'd just be on the main floors, and we're not talking direction indicator. So in the, you know, we're not talking about where the elevator is. If you're standing at the main lobby, for instance, you're not, you know, looking at a little LED thing above the hall doors telling you, hey, the elevator's on floor 16, it's coming down to get you. We're talking about hall lanterns, basically with an up and a down, you know, indicator, whether it's a circle or an arrow. Doesn't get too much into that. Just the fact it can't be flushed or recessed. And this is going to be one for every elevator. And this applies for 2-floor buildings. It applies for 80-story buildings. And this is on every floor for every entrance you have. So basically it's going to allow someone that's, again, low of sight or has mobility issues, clear indication as to what elevator is coming to get them and whether it's going up or down. So this is a really important one. I think this is one that's, again, really often missed, but it's a clear requirement. And it's honestly pretty easy to meet. It's just got to get caught during the design phase. Level 3 compliance. This was where, so again, this would be the expectation by IO, Infrastructure Ontario, is that this would apply to all new buildings that are Government of Ontario buildings again, or buildings that want to say they're AOTA compliant, right? So especially buildings that are, I've run into this before too, it's buildings that are getting government funding, or if you want to have a government person in your building in the future from a lease perspective, you know, the Government of Ontario is going to come out and do an audit on your building before they take lease, and they're going to go, well, you're not AOTA compliant, so we're not going to rent space from you. So they're do a lot of this stuff, and they're looking for level 1, level 2, level 3 compliance, right? So call buttons, clear floor space. We talked about this again. So this is a bit bigger than level 2. Panel centered on clear floor space. So this is a really important one. So this is the car panel in the elevator. It's actually no longer typically on the return. Now you could put it on the return, but if you've ever been on a transit line lately, and we'll show you some pictures later on, the COP ends up being in the middle of the elevator, the car operating panel where all the buttons are and the display is. It ends up being not near the doors, but more towards the middle of the elevator to meet this.
We have a slide coming up too where you'll see where this is defined. It becomes an issue in the hall as well, to be honest, not just in the car itself. So we got an image that explains it a little bit better.
Elevator cap should provide clear floor space. So again, we're getting a bit bigger now, right? So now we're talking about the size of the elevator. Again, clear floor space in our business equals capacity. So you'll see this, you know, we're getting into a larger elevator, right? So physically having to design larger shaft to accommodate that larger elevator. Provide guide dogs and handler enough space. So again, they're taking these requirements from, you know, major CNIB, Canadian National Institute for the Blind, Rick Hansen Foundation. They've gone out and they've really done their due diligence trying to figure out how can they accommodate the most people.
I think sorry, but I just might be worth emphasizing that point that it says excluding return panels. So if you see an elevator, you know, there's obviously a recess at the door and then the return panel is next to it. So that clear floor space is measured to the face of the return panel, not to the face of the door, which would give more space, of course, right? So it's just really important when you're laying out your elevator cab that you're applying these dimensions in the right way, right? Again, because it's going to result in a bigger cab ultimately. That little recess in the doorway is not considered part of the usable space of the elevator.
And I know we talked about Appendix E a long time ago now at this point in our presentation, but voice enunciation is a level 3 requirement for all elevators. So, but Appendix E does say anything over 200 feet per minute should have voice enunciation, right? So, basically most elevators at this point should have them. It's just, and this one's actually calling it for all elevators regardless of speed.
So that would basically, for the most part, apply to hydraulic elevators. In the past, for slower hydraulic elevators, we didn't need to put voice enunciation. It would simply have a floor passing tone. It would do a beep as it passed the floor, right? But now, if you want level 3 compliance, like Devin says, you have to add it for even those slower elevators.
And this one here does actually, this is two-way video audio communication. You'll notice previously in the compliance, we actually talked about having video ability to basically communicate with people that have low hearing. So this requirement is called two-way video audio communication. It was a bit confusing because we already talked about this one as well in the previous levels, but this is just a bit more clarity. It's got it again for level 3. This is actually a code requirement for all new elevators, regardless anyways in Ontario. I'm not talking about barrier-free stuff. You'll see here, there's a little bit of a thing here. We basically need to be able to see inside the elevator. This is the video part of this. We need to be able to see inside the elevator, to see the whole floor space. Most of the elevator companies kind of have this down pat at this point because it is a code requirement. Some of the biggest things we're seeing though is like, how do you now have to you got phone lines traditionally to an elevator. Now you've got to worry about video. Is it okay to transmit video? Does the building have a policy? Does the owner have a policy about seeing video? What about getting on the building network for internet service? Because now you're going to need internet to your elevators as well, which in the past was kind of an optional thing, but no longer, because you now need to be able to get the video out to that 24/7 call center to meet code, right? So the little things seem really, really easy until you're about to turn over your elevator and you can't figure out a way of getting the internet to the elevator system. Yeah. Standards and codes, facility accessible design standards. So these are basically in place in Ontario. They started out in London. Ontario was the first one to come out, at least to my knowledge, with a facility accessible design standard. They're generally not mandatory unless you're doing work within that area, right? So Hamilton has one, London has one, Toronto has one, various municipalities have them. And they typically have a lot of requirements, and some specifically for elevators. Again, they don't make it easy for you. They give you you can see on the right-hand side, the facility accessible design standard for London shows a floor space inside the elevator. They don't tell you the capacity is 3,500 pounds. But if you measure it all out and take all the measurements, the smallest elevator you'll find that meets that requirement is a 3,500 pound elevator. And if you're designing a building that's being funded by the City of London, or as a low-income building, low-income housing for the City of London, they want to meet the accessibility design standards to get the funding that they need. You have to meet these requirements. Wheelchair maneuvering, multiple users waiting safely, or talking about the clear floor space requirements. Talking about circulation routes, not hiding the elevators. Don't put the elevators down at the end of a hall, right? They want to be kind of in the main circulation route of the building. And a lot of these are doubling up, right? We already talked about accessible two-way communications and visual and audible emergency signals. And there's actually a number of places that thank London for their facility accessible design standard in their accessibility design standard, because they basically just parroted what London did. City of Toronto's had theirs for a while as well. Theirs for a while were kind of wacky from an elevator guy's perspective. They had some elevators in there that didn't really exist in the real world, but they've kind of since updated their standards a number of years ago. Elevators required where barrier-free access is needed between floors. So I think that's really important too, is that you've got that barrier-free access between floors is required, where that's a unique requirement.
That's different than what we talked about in the building code earlier, right? Because the building code said, oh, you could use a disabled person's lift, you could use a lula, or you could use a ramp also. This says, no, you must use an elevator.
Yeah. Cars must be sized to accommodate mobility devices with turning space or clear floor. So again, getting into, they're going to give you the size, but what does that mean from a capacity perspective, right? Larger than code car dimensions. So we're not talking about stretchers anymore, right? To meet these requirements, we're talking about like larger turning circles for a scooter, for instance, or a person who's got low visual mobility, and they've got a dog, right? So that's where some of this stuff is coming from, right? So. Elevators must include audible floor announcements. So again, we talked about this previously, but this is in the Facility Accessible Design Standard for Toronto. Visual indicators, again, talked about previously, but in the Facility Accessible Design Standard, Toronto wants it. So no, we're not talking about AOTA, now we're talking about the Facility Accessible Design Standards in the various regions throughout Ontario. Again, another example, St. Catharines, right? Elevators should include mirrors to aid backing out of wheelchair users. So you're doing work in the city of St. Catharines and they want you to meet their Facility Accessible Design Standard and their building permit, then you're going to have this. This is not about AOTA, this is about the Facility Accessible Design Standard within the limits of St. Catharines, right? So handrails on at least one wall. Interior design should support stability and orientation. So again, talking about the coloring, the luminescence of colors, the difference of colors within the cab. Out of adequate clear opening width, right? So they start spelling out the width of the doors and stuff like that. Again, not maybe above and beyond Appendix E. Include full height safety sensors. That's in the elevator code, but you know, St. Catharines is making sure that it's also happening within their boundaries. Remain open long enough for safe entry and exit. This is a touchy one too, right? This kind of impacts elevator performance, but most elevators have the ability to, you know, adjust their door opening and door close times to allow for that low mobility user. Brantford, similar, right? Have sufficient clear opening width, stay open long enough for safe entry, be within reach, designed with tactile, lettering, and braille. High contrast to locate. So you can see there's a lot of repeating here, right, between these Facility Accessible Design Standards. Standards and codes, accessibilities across across Canada. Elevators there is actually a requirement for from a national level. Elevators are essential for accessing travel in a safe manner. Where possible, have a minimum of 2 elevators. Now the key is where possible, right? Where possible, minimum of 2 elevators at any given location. So this is again where possible. It's not required, it's just where possible. 1 elevator that is large enough to accommodate a stretcher. We touched on that before. Elevator control panels that are easily identifiable. Have numbers that are displayed and raised characters. Again, a lot of repeating here, what's in the Appendix E and the various other standards we've already talked about. This is the one that's a good picture here. We talked about this earlier. So you'll notice here on the bottom right-hand picture, the car operating panel is actually in the middle of the elevator. And this is a standard, again, level 3 AOTA compliance. But in this transit project, for instance, and there's a lot of different projects across Ontario, this one has a overall project agreement that basically spells out some requirements. Like in the transit facility, they actually want 70% glass elevators. So you can see there's a lot of glass. They want to have that site and transit visual transparency, right? Flow through design. They don't want front only doors. They want to be able to go in the front door and go out the back door without having to turn around the wheelchair. Centralized COP, we already talked about that. Intercom integration. So this is a really difficult one, especially on transit projects, trying to integrate public address systems into elevator systems. Again, this is a requirement for specific projects. So some projects are a lot more complicated than others, and you've got various requirements you're trying to meet, not just code, but also the PA or the project requirements specific. And that's me. I completed some Rick Hansen Foundation training. Rick Hansen Foundation, you know, they influenced a lot of this AOTA stuff, right? So I'm not going to go through all of these, but again, we talked about a lot of this stuff, right? So AOTA does talk a lot about all these things were taken into consideration. If you go to Rick Hansen Foundation, or specifically the Canadian Institute for the Blind, they've got some stuff that wasn't adopted, but maybe in your building it needs to be looked at, right? Like, for instance, they had yellow, oh, this is it. The door threshold, the elevator cab shall have a yellow brightness strip on the floor to define between the entry to the elevator and into the hall. That is not anywhere else other than what the CNIB is looking for in elevators. And this is a poll question for you all. Are you aware there could be local additional accessibility standards for your elevators?
see if I could click it.
We know the answer.
There's no right answer.
Those
Interesting. A mixed set of responses. That's kind of what we thought. I was wondering how many people were aware at all. Most, in my experience, the lay people, most people not aware that these kinds of extra requirements even exist. So it is, and it's confused. It can be confusing if your head's spinning a bit on all the different standards, and some of them are mandatory, some of them are recommendations, some of them are bare minimum requirements. And then is it government building or not? It can be confusing for sure, right? So I think, yeah, it's interesting, kind of relatively evenly split across the board. I will move through this and I'll take over at this point. I'm going to try to go a little bit quickly here because I know we're running a little bit more behind on time, but inclusive features for elevators. So just a little bit of detail on the more specifics of what constitute inclusive features. We've talked a lot about tactile buttons and braille. So that's what we're talking about. That's a typical car button. It's got the braille and it's got that blue one is a raised marking. They have to be able to feel it. It has to be tactile, right? Raised face buttons. I don't know if you can quite tell, but those buttons sit proud of the panel, and that's a requirement. There is a specific dimension in Appendix E that says to what degree they must be raised. So like a flush panel would not meet code, right? Illuminating buttons, maybe that's obvious. I think most buttons these days are illuminating, but that is actually a requirement for inclusivity. Directional indicating lanterns, we've talked a lot about that. Devin brought it up in a couple instances. That specifically is what we're talking about. That's a lantern. That's one example, at least. It's many different designs, but yeah, it has to illuminate the direction of the elevator, right? The current direction. And yeah, it's important. There were certain cases where that was required in the hall, and there are a lot of elevators out there where these are mounted on the car side of the door, and that wouldn't comply with AOTA, say, for example. Position indicators, that's required in the car only, but that's what we're talking about, is actually the digital indicator that tells you the floor you're at. Slip resistant floors, I think that's named in a number of different standards, but it's something to factor in when you're designing your elevator floor about what specific tiles you pick. No trip hazards at the door threshold. That might be obvious. I mean, part of it is the elevator being level, of course, but part of it also is on retrofits. We quite often, well, we don't see it anymore, but we used to see cases where they would simply lay floor on top and in doing so create a bit of a trip hazard as you walk into the cab, because it would sit proud of the door sill. So that's something that we don't want from an inclusivity standpoint. And smart tech features, which I'm going to talk about in the next slide. Actually, I think Devin's going to take that one. He's going to talk a bit about smart tech. So those are also some inclusive features that he'll expand upon.
Ooh, my turn again. Door detectors detect obstructions and reopen, right? So it used to just be that they were in between the doors. You had to actually almost get in the elevator before the doors would reverse. Now we're watching you as you come towards the doors. So basically 20 inches, 500 mils in front of the elevator doors. We need to see things coming towards the elevator to keep the doors open. It's really good for people with low mobility in a wheelchair or something like that too. As they're approaching the doors are trying to close. They see that person in the wheelchair approaching. Instead of that person now getting in the way of the doors are going to stay open, seeing them come and keeping those doors open longer.
Worth probably noting, in Ontario, this is now a minimum requirement.
Yeah.
Not in every province, but in Ontario it is.
Prevents door strikes, enhances accessibility, and like Eric said, required in code. Touchless buttons, not any code requirements. It's kind of funny. I was reading through CNIB, and they actually don't want this. They want you to touch buttons.
They want you to physically
They
touch
actually
it.
want you to be able to physically touch it, right? So now again, I think it might they because you've got low sight, this could be an issue in terms of, you know, not getting to the button you want if you're trying to fumble around, or not fumble around for lack of a better term. They're trying to find the button that selects the floor, and they may inadvertently press another button because they actually haven't pressed the button yet, right? So
Yeah.
again, we got conflicting requirements trying to make it's really difficult trying to meet all of these.
We don't see a ton of these, but we've seen them. I know downtown Toronto, there's a number of locations where this exists.
Yeah, it's even strange to us. We go out there and we press it. It's like we haven't hit the button yet. We actually touched it, and it does work. I'm not going to spend too much time on this, but again, there's a number of systems out here that are similar. MAD just happens to make this one. And you simply hold your finger over the button. This is, I think, a lot of this stuff came from the COVID era, right? Where we're trying to create stuff that's not being touched and possible transmission. This is, I think this is kind of where we're going with a lot of things these days. So the universal app, everyone's got a smart device in their pocket, and you know, we think nothing of going up and pressing the hall button, but for some people, it's not so easy. So quick little video of this.
Yeah, instead of obviously struggling to push the button, if that is a challenge for you, it allows you to do it right on your phone, right?
This makes a lot of sense. And this is actually, if you go to Peterson Airport, they have an ability to download their app, and you can actually call their elevators and press floor buttons and stuff like that from your smartphone at the airport. It works pretty well. And that's honestly really good, honestly, even for like a busy elevator at the airport, even if you are, you know, don't have any mobility issues and stuff like that. It makes it easier to be standing in the middle of one of those large elevators with all your luggage and tell what floor to go to. Phone app access, how it works. You know, this isn't right off the bat, right? This would have to be an upgrade. Most elevators, this is not a code requirement. This is something we'd have to discuss during design, or an upgrade that could be put on, like the ones at Pearson, for instance. Those were put on during the COVID years to allow for enhanced accessibility.
But you can add it after the fact.
Yeah,
I think that's the point there, right? It's something that, yes, like this with this Elevate Me app that we're showing right now. This is a Schindler version of it. It's a phone-based app. Yes, this is something that would come with a new build. The previous MAD solution we showed you, that's something that can be added after the fact. So you install an elevator, it doesn't have that any kind of phone app access, and then now it does, right?
And so, you know, most of the major elevator companies have a system like this. This is just Schindler's example, but here, we'll just pay a little quick
This
video.
is Schindler. I had a system. I got on floor 2. The elevators, they come, and there it opens. And when we walk in, you'll notice the second floor is lit. And it will take us to the second floor and let us off. It works seamlessly, phenomenal system.
Going back to the start of this, though, I saw a lot of stuff that didn't meet IOTA, right? He's got his hall lantern there. It is buried on the door jamb. Your button itself doesn't really have its clear space. So there's a lot of stuff in this nice video about accessibility, but doesn't actually meet any of the stuff that we just talked about.
Yeah, he seems quite pleased with it.
He's very pleased. He did not attend this presentation. Oh, more fun questions. What inclusive features have you used on projects?
I'm curious.
There was a hint given earlier.
No right answers. Let's see the results. Yeah, that's the response we like to see. 73% rely on the elevator expert. Yeah, interesting. Yeah, I mean, to be honest, what we are seeing, as much as we hear about the smartphone apps, I don't see a lot of people using it. It's lots of talk about it, but contactless buttons, yeah, probably consistent with what we're seeing in the poll results, slightly more prevalent than the phone app. 3D door detectors, I suspect that's maybe just lack of awareness, because if you are doing a project that involves a retrofit of an elevator or a new elevator, it would have, in Ontario at least, it would have a 3D door detector.
Yeah, ever since about 2002, it's been kind of a code requirement in Ontario for elevators installed after 2002. So, or registered, I should say.
All right. User safety and comfort. What, as it pertains to accessibility, I mean, user safety and comfort is key, right? So what are some of the things we're looking for? Larger elevator, cabs, and doors, and there's a whole series of requirements that we've talked at length about. How big do the cabs have to be? How big do the doors have to be? It really depends where you are, what the requirements are. Clear space, we've talked about that a lot. I thought it would be good just to see a little bit of an image of how that would be laid out. So that clear floor space has to be centered on the button itself. Okay, so that's the hall button that's shown out on the lobby side. Quite often would be located almost right against the wall, or sometimes we would see that, or we'd see it on the opposite side of the elevator, right next to the door, and also right next to a wall that's coming down adjacent to the elevator. And that results in a non-compliance, because it's not just the total amount of space you have, but the fact that that clear floor space has to be centered on the panel, not like the one up top. The one up top is actually shown incorrectly. That should be shown centered on the car operating panel, right? So, and what that clear floor space requirement looks like really depends on exactly whether you're minimum appendix E or whether you're meeting level 1, 2, or 3 compliance in AOTA. So that dimension will change. 1,500 millimeter turning radius in the cab. I think that's fundamentally what a lot of this is based on. I think it's important to just be aware of that. So if you're doing anything custom, that's kind of at the basis of all of this, is they want that minimum dimension to be able to rotate around with that 1,500 millimeter turning radius, as far as sizing the elevator cab goes, at least. Door timing, which we would call dwell time being how long do the doors stay open, not how long do they take to open or close. We do look at that as well, but we're concerned with how long do they stay open before they start to close, right? Then it has to be adequate and customized. And I have actually a case study that I'm going to go over with you quickly to explain how this works. I think I just want to provide a little bit of context, though, for my case study that I'm about to talk about. So destination dispatching, I don't know if anybody has used this on a project, but fundamentally how this works, it's different than a typical system, right? This would be conventional dispatching, a typical system. And when we say conventional, we mean you have up-down hall buttons in the elevator, in the hall, and then in the elevator cab, you have a button for each floor. Right. So basically what happens is you end up people randomly going to an elevator. They're going to go to what elevator arrives first. Right. And regardless of what floor they're going to. Right. So the problem with that is that the elevators go in kind of a milk run scenario. So they're going to a lot of different floors. In this case, maybe only 2 or 3 floors, but if you have a lot more passengers in a full building, you could have 8 passengers and say 6 floors. Okay, not an efficient run of the elevator. So with destination dispatching, what we can do is the system in real time kind of organizes people according to elevators. And you can see now it's allocated people to a specific elevator based on where they're traveling to. So sometimes you end up having to wait a little bit longer, but it'll get you to your floor more quickly because it's making less stops, right? So that's the whole idea here. Now, why is that relevant for accessibility? Obviously, it's more efficient and reduces the wait time like we talked about. But something key that I want to talk about here is it recognizes everybody individually. Everybody has a credential, an individual credential, and it knows exactly who you are and what your user profile is. So it can customize that door dwell time, how long the doors stay open, based on how long it thinks you're going to take to walk or transit from where you've entered your destination floor to the elevator that you're going to pick. So that can be customized, and it's not static. It will dynamically change according to who's using the elevator. Yeah, and it can customize user allocation to cabs based on space requirements. In other words, if you are, say, for example, in a mobility device like a wheelchair, it knows you need more space, it will not allocate as many people to the elevator cab that it's put you in, right? So it'll give you extra space. So this is a specific case that we had. It happened to involve a large building, actually, with 10 elevators. Those are all grouped together. So the problem here was a high traffic building. People were missing their elevators. The doors were opening and closing too fast. And what resulted? High wait times, because people miss their elevators, then they have to call it again, and you start to get people queuing, right, and lining up for elevators. So this was a problem. It was ultimately a programming error is what we found out when we researched this. The system was not recognizing the kiosk. The kiosk is where you enter your destination floor in the hall. It would typically be a touchscreen kiosk, right? Where you would say, I want to go to level 11, and it would allocate you to a specific elevator. System believes, oh, my animation is not coming in correctly. Hold on a second. I will explain this in a second once it goes through. There we go. So let me explain it. Up here was the kiosk. This is the kiosk where they enter. This was the correct kiosk where the person was actually located, but there was a programming error where it thought the person was down here. And so it thought, okay, I'm allocating them to this elevator PE06 down here. So it thought this is a short trip. So it was keeping the doors open for a short period of time, right? Now, what we had to do was basically fix the programming of the elevator. We fixed it so that it correctly recognized that, hey, this person is not right next to the elevator that I'm allocating them to. It's actually a long walk down the hall here, this green line, to get to the elevator, right? And like I said, you can have the system recognize, okay, this is a typical person that will be walking and can walk at a quicker pace maybe, or this person is mobility challenged, or they are in a wheelchair, etc. And it will customize the door dwell time according to how long it suspects it will take them to get there. Because ultimately you don't want people to miss the elevator, right? And so I think the point of all this is that destination dispatching gets categorized as an efficiency feature, that it basically reduces the wait time, which it does, but it also can aid in accessibility, which is something that probably doesn't properly get factored in. So yeah, no, I just thought this was an interesting case that kind of showed exactly the kind of problem that can happen and how we can solve it, right? So basically, this system would keep doors open, not in a specific amount of time depending on where the kiosk is and where the elevator is. So every elevator door would have a slightly different time depending which kiosk was picked. Ride quality. Ride quality is key to promoting accessibility. And what do I mean by ride quality? It's basically the vibration in the elevator. So this is the kind of tool that we would use. So when I say vibration, we ultimately mean acceleration, but how it feels to the average person is like vibration. So you'll see kind of vibrating in the cab either side to side or front to back. And then up and down, that would manifest itself as kind of vibration in your feet. You would feel it, vibration in the elevator cab. So, I mean, it stands to reason if you have an elevator cab that's kind of rocking back and forth or side to side, that's not going to promote accessibility, right? We're also looking at sound levels in the cab, right? Because this vibration can transmit as noise as well, right? So these are the standards we look at. Okay, so we're looking at the 20 milli-G, basically is the acceleration value. We're also looking at acceleration, how fast it speeds up, and then jerk, how fast the acceleration changes, right? That's that kind of, when you have a high rate of jerk, that's going to manifest itself as kind of like that feeling in your stomach, right? When you take off too fast. So these are the kind of graphs, the outputs that we get, and there's a lot of data here, and I don't need to copy go through it in detail, but the bottom line is we're looking at that range from top to bottom between these lines. So this would be kind of the 20 milli-G option right here, and this would be the 10 milli-G option here, right? So we're looking at, okay, that vibration isn't within. You can see the graph on the right is it's perfectly within the required boundaries, whereas if 10 milli-G, which is a very tight requirement, is what we're looking for, we can see little spikes outside of that. And this is time on the bottom, so this is basically location in the building. So this is the elevator traveling kind of top to bottom throughout the building. So what can we do by measuring that ride quality, right? We can improve the comfort. I talked about that jerk, what we call a jerk. We try to minimize that jerk or bring it below a certain value at least, so you don't get that uncomfortable feeling, or that it's such that it affects your stability in standing in the elevator cab, right? That vibration can be an issue. We've seen a number of buildings where that front to back movement or side to side movement can be significant, right? It can be an issue. So this is a tool we can use to kind of measure that. So, poll question: what do you feel is the most important user safety comfort feature to consider? User space in front of the hall and car buttons, being able to reach an elevator, the door timing issue that I talked about, or the last topic, ride quality and acceleration, deceleration. What would you consider to be the most pertinent? I don't know there's a right answer on this. I'm just more curious what people think.
I feel like we should have Jeopardy music.
Across the board, yeah. A lot of these questions are getting kind of evenly distributed, relatively speaking. I kind of, I mean, my personal feeling is probably consistent with this. I think the first and foremost, you got to be able to get an elevator. If you can't get an elevator, that's probably the most important thing, and making sure that the elevators are reachable. And then the ride quality, I think, is important. It's not something that you might sense that the ride quality is off, but if you don't get it independently measured, it's really hard. And those graphs, I know there are a lot of detail in them, and they go into the very specifics where in the hoistway the problem is. But I think that's the data that an elevator contractor can take and go about fixing the elevator, because they can also look at the very specific vibration that they're seeing, the frequency of it, and they can determine where the problem might be based on that frequency. So I kind of agree with these findings, to be honest. Bear with me. Yeah. Benefits of user-inclusive design. I think this is our getting close to the end of the presentation. I'll turn it over to Devin to go through this.
So in a lot of our jobs, right, we're asked about, social governance and social diversity and responsibility, right? And I think that's really important when we're designing from an overall building perspective, but we're focused on elevators, obviously, making sure that we're designing to apply to as many of these people as possible. Quite honestly, it's very difficult if you're looking at CNIB and AOTA and Rick Hansen and trying to obviously meeting Appendix E, because that's the bare minimum code requirement. But I think it's very difficult to meet a lot of these all at once. So I think you've got to really try to drill down as to try to what we're going to do. I think we're trying overall, we're progressing here, and we're trying to, like with AOTA, trying to meet more and more of these requirements, whether it's a new construction project or or like I said, we're doing a lot of work for Infrastructure Ontario where we're going around specifically to add AOTA accessibility to elevators that don't necessarily have, weren't installed with them. Improve code compliance, reduce risk of non-compliance, and cost benefits, costly retrofits, right? So, they're trying to overall trying to get us ahead of the game, right? Long-term building value. I think I mentioned it before, like the government, if they're kind of renting space in your building, they will come and audit the building for AOTA compliance before they, sign a contract or something like that for a lease. So long-term value of, of doing this stuff up front, you might spend a little bit more money, but it's going to increase flexibility, and, advertising your building as AOTA compliant is a big deal these days, right? So. Independence for elevator passengers, right? At the end of the day, that's what we're looking for, right? We're not looking for someone to come and ask where the key holder is. We're looking for someone that, out there in the world and wants to get through that building just as easy as you or I or myself does, right? And I think I take this for granted because I'm able-bodied. I don't have a dependence, right? So I'm able to go out there and stand next to a hall button that's right up against the edge. But if I was in a mobility device and I can't actually physically reach the button, but yet I want to call the elevator, how frustrating would that be to you when you're just trying to get through your day, right? So, independence. Meet accessibility needs through the building lifestyle, right? So I think trying to get ahead of some of these, these are going to become, that AOTA that's, not necessarily in every single building as a requirement, in the future, those are going to become more Appendix E values or building requirements in every building. So, actually doing these things up front is going to save you from doing them later on, right? And like anything, or like many things anyways, it's going to be more appropriate to do them up front and more cost effective. Future trends. Gonna kind of quickly go through this just from a habit of time. COP in the middle. It's a European thing. If you've ever been on vacation in the Caribbean, a lot of European elevators in the Caribbean, and they all have their car operating panel in the middle of the elevator. This has been a European thing for some time. Again, transit facilities are a little bit ahead of the game because they have very specific project requirements. They're also dealing with a lot of people in moving throughout the building space. So car operating panels in the middle. We got that 75% glass area for basically, to see the elevator, but also for user comfort and safety as well. COP in the center of the elevator. I just said that. And flow through design. This is an important one too. Flow through design is a problem with AOTA, right? So, not just having a front only elevator. This is a huge, obviously, design thing when you're building a building, right? You want to have a front entrance. You want to go out the rear. You can imagine being in a wheelchair. This is going to stop you from having to turn around inside the elevator. You can just keep going, right? Go in, go out, nice and quick, nice and easy, not having to take up room to turn around your mobility device.
Difficult to pull off sometimes depending on your layout, but
100%.
Yeah.
I like this one. We're all being watched all the time, but we talked about destination dispatch. I think that Schindler and some of their newer systems, and I'm sure the other elevator companies are coming out with stuff as similar as well. They're watching you as you're approaching the elevator, and they're making the decision without scanning a card, without, if it's your first time in the building, there's no user programming. It's just going, hey, I see a person in a wheelchair. I'm going to keep my doors open longer. This isn't like going to happen 20 years from now. This is kind of already happening. It's already on the market. So as we all know, AI is around and it's carrying over to stuff like this, right? So again, no credentials card to carry. You don't have to worry about losing your stuff, real time, happening right away, right? Seamless.
And I would think if you're operating a mobility aid like a wheelchair, that carrying a device would be a bit of an impediment,
Yep.
Right? And having facial recognition could help, in my view at least. This is the Schindler version of it, right? Built-in facial recognition. This is with their port system, their destination dispatch system, right? Basically the same thing, but specifically for Schindler.
So some key takeaways from today: standard code requirements for province and municipality. I think you got to be very aware up front as to what you're getting into, right? Making sure that you've taken all these things into consideration, making some decisions up front right from the start, right? And working with your elevator expert or yourselves up front to make sure you're really understanding what's required in that building, whether it's a new school you're building or designing, or whether it's an accessible condo or Class A office building. Smart tech, touchless buttons, contactless access. There's a lot of different stuff out there. Again, not code required, but stuff that could be in that Division 14 document. User safety and comfort, destination dispatch. We're seeing that on more and more buildings, right? Even condos and stuff like that. Not just it started in a Class A office environment, but it's really getting out there in the world. Right, quality analysis, benefits, quality, future proofing your building, making sure you've got that independence for everybody in Ontario. Future trends. I like the future trends, but again, like I said, it's here now. Facial recognition, compliance with recommended standards above and beyond minimum codes, that flow through design, especially in those 2-floor, 3-floor situations where you're trying to move a lot of people, that really does make a lot of sense. And that is it.
That brings us to the close of the presentation. You're welcome to get in touch with us. I believe we're going to be sharing a copy of this presentation, right, Shalika?
Yep, with the attendees. The PDF will be
Yes.
sent out. Yeah.
Yeah. So our QR codes with all of our contact information are there. If QR codes are not your thing, we do have our email addresses there as well.
Perfect. Great. Thank you so much, Devin and Eric, for a great presentation. We are shifting into the Q&A portion now. So if you haven't already, please go ahead and submit your questions for our speakers in the Q&A box. You'll find that at the bottom of your screen. There's a few questions in there already, so we can get started with those. Okay. So someone has mentioned here that the NBC and accessibility requirements have moved to an 1800 millimeter turning radius. How does this change things?
I don't know. I'm not familiar with 18 millimeter turning radius. To answer that question, what I know is a 1500 mil turning radius. Obviously, how would it change things if it were a requirement? It would result in a bigger cab, because it would mean that elevator cabs that currently comply with Appendix E, for example, a 2,000-pound cab with a side parting door would meet Appendix E, but that's based on a 1500 mil turning radius.
Yeah, I think it does. It does that 1800 millimeter turning radius actually applied to within the elevator, right? I think a lot of times they used to take old washroom code and then stick it, make that application for the elevator where it didn't necessarily apply. Like Eric said, anything about space in our industry is going to increase the capacity of the elevator.
I'll look into that though, just to verify. Just what I'm familiar with, what I know is NBC requires Appendix E, and Appendix E specifically talks about the 1500 mil. Well, to be specific, it doesn't actually refer to it, but it is based on it. Ultimately, is based on it, and so yeah, it wouldn't comply with the 1800 mil requirement.
Okay, thanks. Okay, so next viewer has asked, when you have front and back doors, where do you put the mirrors that are required on the back wall of the elevator?
You don't have to. Yeah.
Oh.
That's the bottom line. Yeah. It's only when because that would be a flow through design, right? So when you don't have a flow through design, then you wouldn't need it.
And I've actually ran into, like, on IO projects where we're going around taking the mirrors off the sidewall in the front and rear elevator because it had mirrors, and it's not allowed to have mirrors on the sidewalls anymore. So they are now going around removing the mirrors and putting panels in.
Okay. Makes sense. Okay. We have a question here. So your presentation seems to say that local municipal requirements can supersede the OBC, except for municipally owned or financed projects. This may be considered misleading. Have you experienced any pushback by project proponents on this matter?
I mean, I haven't. I think it depends on the project, of course, right? It depends on the specifics of the project. So yeah, at the outset of the project, it will be clearly laid out about whether they're required to meet a certain design standard, right? For accessibility to the standard in this case. So the vast majority of projects that we deal with, it's mostly just Appendix E compliance. That's for the most part what we're looking at, i.e. building code compliance, right? But if I think where you have to keep it in mind is on these municipal projects that are government funded or government occupied buildings. So and this it goes beyond accessibility. To be honest, there are elevator standards that go beyond accessibility requirements for, different, municipalities, different hotel groups, different developers, etc. They all have kind of slightly different requirements that can kind of go over and above what might be the minimum in code. So I think we're always kind of simultaneously evaluating both of those things, right?
I think for the most part, though, they actually every case they actually do exceed the requirements in the Ontario Building Code, right? They're not below the standard that the Ontario Building Code sets out, right? So
Yeah.
if the Ontario Building Code is saying one thing, that the requirements that we've talked about a lot of times in this presentation are actually above and beyond what the OBC requires. So you're going to meet the OBC.
I think the last part of the question is about pushback, which, sometimes you do get that. You do get that on various requirements. I know we're doing a transit project right now, for example, where we're critically evaluating some of them are accessibility requirements, some of them are other related requirements for the elevators and escalators. And yeah, we definitely have to kind of evaluate whether they make sense, right? And where necessary, we do push back. So.
Yeah.
So I think, yes, sometimes we do get that.
There's one I can think of now that's got huge cost implications that we're trying to work through, right? But would break the project agreement.
Right. Okay. Someone has asked here, so with all the different standards, would this in a general sense be equivalent to numerous codes being applicable? And they put in quotation marks here. In the event of numerous requirements, the most restrictive condition governs, i.e. you can't choose the minimal requirement and not comply with the most rigorous.
Yeah, that's life in the elevator world, to be honest, because there are a number of conflicting requirements. And again, I'm going to kind of tiptoe out of accessibility, and when it comes to something as simple as say firefighters access and firefighters emergency operation, what the building code says is less than what the elevator code says. So we have to comply with the most stringent code, which is the elevator code. So we're continually evaluating, okay, do we have a municipal standard? Do we have an owner standard? What about the building code? What about the elevator code? And it's kind of continually evaluating between those and figuring out what is the most stringent requirement across the board. So yes, that's fundamentally what we deal with on an everyday basis, to be quite honest.
Right, gotcha. A more general question here. Someone has asked, when is an elevator not required between floors?
Yeah. I mean, if we're not let's put aside the discussion about AOTA compliance and Ontario, government building design standard, right? Put that aside for a moment, because as we talked about, that did require a proper elevator in most cases, right? The other options are a Lula elevator, which is like a small elevator, and it doesn't fit a stretcher and it doesn't meet Appendix E. So it's not a proper elevator per se, although it's called a Lula elevator, limited use, limited application. Or we could put a disabled person's lift, which of course we've talked about the pluses and minuses of that. And then you've got a ramp. Those are the options. Now, when you look at the building code, that's what it says. So in other words, if you don't have an elevator in a building and you happen to have ramps between the floors, in theory, that would be compliant to code, right? So as long as it was a municipal government or a Ontario government building, say for example, you wouldn't need to do that. You could just put ramps, for example. And we do see some buildings that, not many of them these days, not many, really not many, but occasionally they will have, say, a Lula or a handicap lift, providing access between two levels.
You could think of like a condo, like at a private residence, where you'd have like a 2-floor condo within a private residence, where you wouldn't necessarily have an elevator because it's a private space that wouldn't necessarily have that enforcement, and the elevator might have 2 floors per condo, sort of thing. I think I've seen that before a couple times.
Yeah, actually, that's a good point. Yeah, I didn't think to mention that, but yeah, of course, if it's not a public building, it's a private residence, none of this applies, right? So you can do what you want, really.
Right. Okay. A follow-up question relating to mirrors. Someone has asked, what if you have front and back doors that only access one floor? Only access one floor. Do you need a mirror on the back wall?
I understand the fundamental of the question there. I believe me, I've thought of exactly the same thing. I think it's not entirely clear, because the implication is that front and rear implies a flow-through design, but it wouldn't necessarily, like, I know what he means. He's like, oh, what if I have front and rear at the main level, but at every level above that, I have only front entrances, right?
Mm.
So technically, in my mind, I'd probably want to just review the wording again, just to be certain we're compliant, but I don't believe you would need a mirror.
I had IO actually tell me I didn't know whether they're right or whether they're wrong or not is a different
They said
story.
you did?
Did not.
You did not.
Did not, because we were actually talking about possibly putting a mirror in the return jamb of the elevator next to the door, right? Because
No.
that would be your back wall in that situation, right? And we talked back and forth, and the decision was made not to do it. So
Okay, great.
I don't know. We'd run out of room to put a mirror anyway. So I mean, you probably could fit a very narrow, a fit mirror, a very, very skinny
Right.
mirror, maybe, but that would be about it.
Right. Okay. Someone has said here, I often find in the cab the plaque with the number and braille is much more pronounced than the actual button. It's confusing. Shouldn't the actual button be instinctive and more visible?
Yes. I agree. I mean, I've done that too. Where you go and you try to push the tactile, right? Yeah, like yeah, I kind of agree. It can be a little bit. I think what you're going to see change though, because these accessibility standards, one thing they require a lot of them is visual differentiation between the button and the panel adjacent to it. So for example, a typical panel you would see would be a round stainless button with a nice big black tactile designation next to it that really stands out, is prominent. And then the stainless button is right next to a stainless panel around it, so it has a tendency to blend in, right? So I don't disagree with this anonymous attendee. I kind of agree, but like I say, I think that's going to change because now the design standards are asking for visual contrast on the buttons.
yeah,
So there's not a lot of them that have it yet, but you're going to start to see that. So I think it will help with that issue.
I think in the past too, we had a lot of flat buttons that weren't pronounced from the car operating panel, where you're going to see, like you said, more buttons that are actually coming out of the panel a little bit further.
Right. Okay, great. And our last question for today, someone has asked, if you are renovating a multi-floor building which currently doesn't have an elevator, when are you required to add one?
That's a good question. I think it depends on the municipal kind of appetite. Like what go talk to the city and see what they say. As a rule, it depends on the percentage of the value of the asset that you're spending on the renovation. When you go above a certain threshold, you're required to bring it up to current code. Fundamentally, how the building code works though is in the absence of any such requirement, you cannot, through a renovation or an alteration of a building, reduce the level of safety. So but you're not required to bring it up to current code. It's a little bit different than the elevator code, because the elevator code says if you touch an elevator, for the most part, there are some exceptions, but for the most part, you're required to bring it up to the current standard. Whereas the building code, I think for good reason, has some more relaxation built into it. So you're fundamentally not allowed to make the building less safe. So I would say, generally speaking, you would not have to. That's what we see, at least, is that elevators are not being added when they do renovations. But I would see, like, if you were doing a change of use, I would suspect that they would require it, for example, or like I say, if the value of that renovation went above some percentage of maybe 25% of the kind of value of the building itself, that they may require it.
I've also seen a number though, and again, that's municipality to municipality. It goes to the building department for approval. There's no elevator. It gets sent back. Where's your elevator, right? And it's a simple like 2-floor. They maybe just adding a second floor mezzanine to to an existing building, and they're looking for some sort of elevator between those 2 floors. And you get a panic call at the last minute. What do I need to do here, sort of thing, right? So I think Derek Tussin at the start there. I think it can be very municipality to municipality, even without funding from the municipality. It just that building department is got a lot of power to enforce some of their own requirements. So.
Okay, great.
Yeah,
so
I know something. Sorry, Shalika, but just something commonly that comes up is, let's say, for example, I have an old building, and maybe it even does have an elevator, but it doesn't, for example, meet stretcher accessibility. And that's common. You see an older 2,000-pound elevator, doesn't meet stretcher. It does meet Appendix E, but when we do a renovation of the elevator, it's considered not feasible to upgrade the elevator to meet the current standard for stretcher accessibility. And they clearly do not. Well, again, with some exceptions, if you're spending a certain amount of money or if you're changing the use of the building, they may make you replace the elevator effectively. But that's really, in reality, what would end up happening. So I would apply the same logic to whether an elevator is required or not, right?
Great. Okay, thank you so much. I just have a few closing announcements before we leave off for today, but I wonder, Devin and Eric, do you mind putting up the slide again with your contact information so that if anyone does have any last questions that they're thinking of, they can get in touch with you so they can ask you directly.
Yeah.
And I will, as you're doing that, I will jump right into our closing announcements. So again, a big thank you to Eric and Devin for this excellent presentation, and for our attendees for all of your engagement through the Q&A window as well. So for those of you who are seeking continuing education learning hours, again, a reminder that the OAA will record your participation in this webinar on your OAA transcript, so there is no need for individual reporting on your part. We just kindly ask for your patience at this busy time of year as we process and confirm the accreditation of your hours within the next few weeks. All attendees are going to receive a copy of the presentation as well as a link to a survey to submit your feedback for our speakers today. We at the OEA and our presenters really highly value this feedback, so if you do get a moment to do so, please complete the survey once you receive the link. Our next webinar takes place tomorrow, Thursday, April 16th, with the title Viewing Architectural Fees Through the Lenses of Scope, Value, and Risks. And this one is presented by architect and RAIC advisor and committee member, Yu Thong Long. So if you haven't already, be sure to check that one out. If you're looking for additional ways to get your Con Ed hours before the end of cycle, be sure to check out the Con Ed opportunities page on the OAA website, where we list continuing education opportunities offered by other organizations beyond the OAA. And with that, I will thank Devin and Eric once again for sharing your presentation with us. Thank you all for your attendance, and have a pleasant remainder of your day. Thanks very much.
Thank you, everybody. Bye-bye.